It does not draw power. As a matter of fact, the only time when you draw power is when you want to interrogate. You send the laser pulse into the sensor, and the sensor will respond to the vibration and give you the feedback. You convert the optical signal back to electricity, and there you go. Now, another unique thing about the vibrofiber is we are a true optical sensor. That means the signal, once we grab them, is maintained in the optical form. And then we take it all the way to the control room and where the conversion takes place. The benefit of that is long cables, electrical cable, are like antennas. If you have sensors that convert too quickly, let's say on the cover of your generator, and then run 1,000 meters long cable, you are guaranteed to have a problem of noise. So in contrast, vibrofiber keeps everything optical. And another side benefit of that is all the tools that we use will be inheriting from the telecom industry. And that's the reason why we are able to provide the solution almost at half price of our competitor. So these will become additional benefit for power plant like yours. Vibrofiber has another distinct feature. It is very easy to install. You recall that the sensors made with optical fiber, almost like human hair. And therefore, it is very easy for us to package them into a form that is most suitable to be inside the generator at the end winding. So a few suggestions. First, we recommend that you install the sensor at the location where you expect the highest induced voltage. And to get that, you have to, with the plant engineering, and get the original design drawing. And they will be able to point it out to you. And there is another method that we use to ease the logistics, and making it so simple that to install 12 sensors in a generator, it takes 1 to 2 days only. This compares with our competitor having to do 7 to 10. And you can see the saving involved, because time is money. And the time that you have to leave the machine idle, you're not making money. So give you a little bit more details. So we said take the design drawing and then find out where is the winding with the highest induced voltage. In this case, in phase A, let's say. Okay. Now, at the same time, count the total number of windings in the machine and let the number be n. Take n and divide by 3. There is your magic number to continue with the installation. Simply count clockwise, continue from the location where you have already installed by n over 3, and that will be the ideal location for phase B. Install there and repeat the same procedure clockwise, and you will find the location for phase C. It's very simple, isn't it? As a matter of fact, I want to show you a view graph at the end result of having done that. Again, this is a cross-section of the small hydro generator. And just another way to illustrate the alert capability, remember we show you channel 1 has slightly exceeded the alert limit. And here it is. On the top left corner, this sensor shows that it is now 14. The rest of the sensor show very stable and well within the specification performance. If you turn to the other end of the generator, basically they will be installed in the same pattern. Sensor will be grouped at 120 degrees apart. However, the problem you saw in the top left now became the top right. As you can see that the winding on both ends is like mirror image. Now, I'd like to point out one additional point is that the end winding vibration came originally from the stator itself. Why? Because you notice on both the left and the right, and they are different mechanical structures, and yet they're consistent. And you see at the other windings on the drive end and the non-drive end, they all show the same amplitude. So this further proves that the vibration, SEW vibration, actually came from the body of the stator itself. Physically, just want to show you a picture how the sensor is installed. Okay. Now, this is also inside the small hydro power plant, and there the end winding has very well defined end cap, so allowing you to distinguish what is the radial or the tangential direction, or if you like, what we call the X and Y. Now, the vibro fiber, although it is like a hair and obviously it should be responding to all directions, but because of the way we package it, it is only sensitive to one direction, and that direction is orthogonal to the package. You also notice how thin the package is. This is 7 millimeters. By the way, this sensor is built for low temperature, like a hydro plant, and so the material is white. For larger generators and expecting temperature to be higher, we have the same sensor package in a different material called polycarbonate, and the sensor will be black and easy to tell them apart. So the black vibro fiber sensor will be able to stand up to 150 degrees C. And by the way, most of the insulation is rated to 130, 150. So you will never see temperature much below that because the generator will simply stop working. And here is another view graph showing sensing the tangential direction. Okay. Now, we use a high temperature epoxy that has been tested many years. And this epoxy is so strong that once we cure it, it would be impossible to remove the sensor without destroying it. Now, the amount of protection in the hydro, because there is no hydrogen cooling gas, things are in good shape. So simply attachment is okay. In the next webinar, SEW2, where we will be showing you the installation of the Perky plant, which is a much larger generator, the attention to detail there, it is much more elaborate. But still, it does not take us that long, 2 days, to install 12 sensors. We have so far talked about how end winding vibration or vibration in general affect the life of your generator. Now I want to mention another thing which is related. Well, you can have problem by the rubbing, and that is caused by looseness and the vibration amplitude to grow. But another thing that you can do to the generator to shorten its life is to run it at elevated temperature constantly. The winding insulation, remember, is temperature rated, and this function will be affected if the temperature goes above 100 degrees C. And that's the reason why everybody trying to keep that temperature below. Now, in a large generator that is hydrogen cooled, so you will also find the end winding